B-52 Stratofortress first flew when Dwight Eisenhower was president. That was 1952. And here's something that will blow your mind. The Air Force just announced this bomber will keep flying until 2050. We're talking about a 100-year service life. But here's what nobody's telling you. The B-52 rolling off production lines in the 1960s and the B-52 flying combat missions in 2025 are not the same aircraft. Was busy watching stealth bombers and hypersonic missiles, the Pentagon quietly turned this Cold War relic into something that has America's adversaries completely rethinking their defense strategies. And the twist? Some of these upgrades make the B-52 more capable than bombers that cost 10 times as much. What you're about to discover will change everything you thought you knew about strategic air power. The B-52 just received modifications in late 2024 that sent shockwaves through defense circles worldwide. But before we reveal what those were, you need to understand why the Air Force is pouring billions into a bomber that's older than most pilots' grandparents. The answer involves capabilities so critical that they're reshaping America's entire nuclear and conventional deterrence posture. Today we're breaking down the 5 upgrades to the B-52 that are turning heads at strategic command and keeping adversaries up at night. This isn't your grandfather's Buff. Boeing and the Air Force took 7 decades of combat-proven reliability and merged it with technology so advanced that parts of it won't be fully operational until 2028. From engines that will save billions to radar systems that can track stealth cruise missiles, this bomber is rewriting the rules of strategic aviation, and every single upgrade we're covering today is backed by official Air Force data and defense contract announcements from 2023 through 2025. Let's start with the most ambitious re-engine program in aviation history. The B-52 is getting 8 new Rolls-Royce F130 engines. And this isn't just a maintenance upgrade. This is a complete transformation of what this bomber can do. Here's where it gets interesting. The current TF-33 engines have been in service since the 1960s. They're so old that the manufacturing tooling doesn't even exist anymore. Replacement parts have to be reverse engineered or salvaged from museum aircraft. The Air Force has been cannibalizing static displays just to keep the fleet flying. The F130 engine program, worth $2.6 billion, will replace all 608 engines across the entire 76 aircraft B-52H fleet. Rolls-Royce is building these engines in Indianapolis, with deliveries starting in 2026 and installation beginning in 2028. The first re-engined B-52 will achieve initial operational capability by 2030. But here's the kicker. These new engines will increase fuel efficiency by 30%. On a bomber that can already fly 8,800 miles without refueling, that's a game changer. We're talking about an additional 2,640 miles of range. The B-52 will be able to reach targets it couldn't before, or hit the same targets while requiring fewer aerial refueling operations. The strategic implications are staggering. In a Pacific conflict, tanker aircraft become high-value targets. Reducing refueling requirements means fewer vulnerable tankers in contested airspace. It means the B-52 can loiter longer over target areas. It means more flexibility in mission planning and routing. The F130 produces 17,000 pounds of thrust per engine. That's actually less than the old TF-33s, but here's what nobody tells you. The new engines are so much more efficient that the B-52 gets better performance with less raw power. The aircraft will maintain its 650 miles per hour cruise speed and 50,000-foot operational ceiling while burning significantly less fuel. And there's more. The new engines reduce the B-52's infrared signature. Modern surface-to-air missiles track heat signatures from jet engines. Cooler running, more efficient engines make the bomber harder to detect and engage. The Air Force ran thermal signature analysis in 2023, and the results showed a measurable reduction in detectability. The maintenance savings alone justify the program. The TF-33 engines require intensive upkeep. The F-130 engines are commercial derivatives of engines already flying on Gulfstream and Bombardier business jets. Parts are readily available. Maintenance intervals are longer. Reliability is exponentially better. Boeing estimates the re-engine program will save the Air Force $19 billion over the life of the fleet. That's not a typo. $19 billion in fuel costs and maintenance expenses that can be redirected to other capabilities. But new engines are just the foundation. What the B-52 does with that extended range reveals an upgrade so advanced that it leapfrogs a generation of bomber technology. And it involves a radar system that turns this 70-year-old airframe into a sensor platform that rivals anything in the American arsenal. The AN/APG-79B4 radar being installed in the B-52 isn't just an upgrade, it's a quantum leap in capability. This active, electronically scanned array radar represents one of the most sophisticated systems ever installed on a strategic bomber. Raytheon delivered the first production units in September 2024. The radar completed developmental testing at Edwards Air Force Base in early 2024, exceeding every performance metric the Air Force established. Full operational capability is planned for 2026. Traditional radars have a physical antenna that mechanically scans back and forth. The APG-79B4 uses thousands of tiny transmit-receive modules that operate independently. This means it can simultaneously track air threats, map ground terrain, detect maritime targets, and provide targeting data for precision weapons. Here's where it gets crazy. This radar can track stealth cruise missiles. Modern cruise missiles are designed to evade detection through reduced radar cross-sections and terrain-following flight profiles. The APG-79B4's advanced processing algorithms can detect these threats at extended ranges, giving the B-52 crew time to react. The system provides synthetic aperture radar mapping with resolution sharp enough to identify individual vehicles on the ground from 40,000 feet. The maritime modes can detect and classify ships at ranges exceeding 200 nautical miles. In anti-surface warfare missions, the B-52 becomes a targeting platform that can coordinate strikes across vast ocean areas. But the real game changer is the electronic protection capability. The radar uses low probability of intercept waveforms that make it extremely difficult for enemy systems to detect that they're being scanned. The B-52 can gather intelligence on enemy air defenses without revealing its presence. The mission computer processes radar data in real time, fusing it with information from other sensors and data links. The cockpit displays show pilots a comprehensive picture of the battlespace, integrating threats, targets, and friendly forces on a single screen. The radar modernization ties directly into the next upgrade, which involves weapons that didn't even exist when the B-52 first flew. We're talking about a carrying capacity that makes this bomber the most versatile strike platform in the Air Force inventory. The B-52 can carry 70,000 pounds of weapons. That's more than the maximum takeoff weight of an F-16 Fighting Falcon. But it's not just about quantity, it's about the diversity of weapons this bomber can employ. The internal weapons bay can hold 27,000 pounds of ordnance. The external hardpoints add another 43,000 pounds. That's 8 weapon stations under the wings, each capable of carrying multiple munitions on rotary launchers. Here's what the B-52 can carry in a single loadout. AGM-86. See conventional air-launched cruise missiles. AGM-158, JASSM. Extended Range Cruise Missiles. AGM-158, BJASSMER with 600-mile range. AGM-158, CLRASM anti-ship missiles. AGM-18, 3AAR-RW hypersonic missiles. GBU-31J, DAM GPS guided bombs. GBU-38 smaller, JDAMs. Mark 62 quick strike naval mines, and that's just the conventional weapons. The strategic nuclear mission gives the B-52 access to AGM-86, B air-launched cruise missiles with nuclear warheads, and AGM-129 advanced cruise missiles. The bomber can carry up to 20 cruise missiles in a single sortie. But here's what changed everything. In 2023, the Air Force completed integration of the LRASM anti-ship missile on the B-52. This weapon was designed to hunt and destroy enemy warships in contested environments. It uses onboard sensors and artificial intelligence to identify and engage targets without GPS or data link support. A single B-52 carrying 12 LRASMs becomes a ship killer that can threaten an entire enemy naval task force from 350 miles away. In Pacific scenarios, this creates what strategists call anti-access area denial in reverse. Chinese or Russian naval forces suddenly face bombers that can saturate their defenses with autonomous missiles from beyond visual range. The AGM-183 AARRW hypersonic weapon takes this even further. Though the program faced developmental challenges, successful tests in 2023 and 2024 proved the B-52 can carry and launch hypersonic boost glide weapons. These missiles travel faster than Mach 5, following unpredictable trajectories that current defense systems cannot intercept. The combination of extreme speed and terminal maneuvering makes hypersonic weapons nearly impossible to defend against. The B-52 doesn't need to penetrate sophisticated air defense networks. It launches from outside the threat envelope, letting the hypersonic missile cover the final distance in minutes while evading all defenses. The internal weapons bay received modifications in 2022 to accommodate the Common Strategic Rotary Launcher. This system dramatically improves weapons handling and reduces the time required to reconfigure the bomber between missions. Crews can swap from conventional to nuclear loadouts in hours instead of days. And here's something most people don't know. The B-52 is being integrated with the Rapid Dragon program. This system uses palletized munitions that deploy from the cargo area of transport aircraft. Engineers are adapting it for the B-52, potentially allowing the bomber to carry and deploy dozens of networked, air-breathing cruise missiles in a single pass. The B-52 just became one of the most connected aircraft in military aviation. And this capability transforms how the bomber fights. The advanced battle management system installed across the fleet integrates multiple communication and data link systems into a unified network. The bomber can now exchange targeting data, threat information, and mission updates with other aircraft, ground stations, ships, and satellites in real time. Link 16, Tactical Data Link, allows the B-52 to participate in integrated air operations with fighter aircraft, AWACS, early warning planes, and ground-based air defense systems. The bomber receives threat warnings, updated target coordinates, and mission changes while airborne. The military satellite communication system provides global, beyond line-of-sight connectivity. Crews maintain contact with strategic command centers regardless of where the bomber operates. This enables dynamic retasking during long-duration missions. Here's the real breakthrough. The B-52 is being integrated into the Joint All-Domain Command and Control Network, known as JADC2. This Pentagon-wide initiative connects sensors and shooters across all military services. A Navy destroyer detecting a target can pass that information to a B-52, which engages with precision weapons, with Army air defense systems providing overwatch, all coordinated in real time through automated networks. The November 2024 operational test demonstrated this capability. A B-52 received targeting data from an F-35 fighter, coordinated with a Navy Aegis cruiser tracking air threats, and employed weapons while Army ground stations provided electronic warfare support. The entire engagement happened through automated data sharing with minimal crew workload. The cockpit displays were completely redesigned as part of this upgrade. Large format color screens replaced the analog instruments that dated back to the 1960s. Pilots now see integrated tactical displays showing their aircraft, friendly forces, enemy threats, target areas, and mission parameters on intuitive touchscreen interfaces. This is where it gets really interesting. The B-52 was never designed to penetrate heavily defended airspace. That's the B-2's job. But recent upgrades have given the buff survivability capabilities that would shock anyone who remembers this bomber from the Vietnam War. The AN/ALQ-172 electronic countermeasure system received major upgrades in 2023. This defensive system detects enemy radar emissions, identifies the threat type, and automatically deploys tailored jamming responses. The system can disrupt surface-to-air missile tracking radars, making it difficult for enemies to achieve firing solutions. The upgraded system uses cognitive electronic warfare techniques. Artificial intelligence analyzes the electromagnetic spectrum, identifies threats, and selects optimal countermeasures faster than human operators can. The system learns from each encounter, adapting its responses based on enemy behavior. The AN/ALE-155 Advanced Threat Countermeasure Dispenser was integrated in 2024. This system deploys chaff and flares with unprecedented precision. Rather than simply dumping countermeasures, the ALE-155 calculates the optimal deployment pattern based on the specific incoming threat. Against radar-guided missiles, it creates false targets. Against infrared seekers, it generates heat signatures that mimic the bomber's engines. Infrared countermeasure systems were added to reduce vulnerability to heat-seeking missiles. Directional infrared countermeasures detect missile launches and project laser energy to disrupt their guidance systems. This layer of defense complements the traditional flares and chaff. But here's what ties it all together. The integrated defensive suite coordinates all these systems automatically. When a surface-to-air missile launches, the threat warning receiver detects it. The electronic countermeasure system jams the tracking radar. The infrared countermeasures engage the missile seeker, and the dispenser deploys optimized chaff and flare patterns, all within seconds and without crew input. The B-52's large radar cross-section remains a vulnerability. Engineers can't change the basic airframe, but they've reduced certain signatures through selective application of radar-absorbent materials at critical reflection points. These modifications, combined with improved electronic warfare capabilities, increase the bomber's survivability in modern threat environments. The B-52 Stratofortress proves that innovation isn't just about building something entirely new. Sometimes it's about taking proven excellence and upgrading it with technology that didn't exist when the original design first flew. From engines that will save billions and extend range by thousands of miles, to radar systems that can track stealth threats, from hypersonic weapons that make defenses obsolete, to network connectivity that turns the bomber into a node in a joint all-domain battle network. The B-52 represents a different approach to strategic air power. One that delivers massive capability right now while staying relevant decades into the future. The Air Force expects these upgrades will keep the buff flying until 2050 and possibly beyond. That would make the B-52 the longest-serving military aircraft in history. These aren't just upgrades. They're a complete transformation of what this iconic bomber can do, and every modification makes it more lethal, more survivable, and more relevant in an era of great power competition. If this changed how you see the B-52, hit that like button and subscribe for more deep dives into the technology protecting American skies. Thanks for watching, and we'll see you in the next episode.